everyone, and welcome to our webcast today, which is the fourth in our Transform Your Business webcast series. Today's webcast is big news about big data, what's new in historian applications. My name is Amanda Gordon. I'm the Senior Marketing Programs Manager here at Iconix, and thank you for joining us today. I'd like to go over a few housekeeping rules. Right now on the webinar, you are in a listen-only mode. If you have any questions throughout the webcast, please type them into the question section of the GoToWebinar panel, and we will take some time at the end to answer those questions. With that, let me introduce our presenters for today. So presenting for us today, we have two people from some of our international offices. We have Jan Maricha, who's in our Quality Professional Services, and his email is listed here below. And we also have Roberto Penso, who's a Regional Solutions Manager in Italy. And Jan is in the Czech office. And you can see Roberto's email is here as well. And with that, I will turn things over to Roberto, who will kick things off today.
Thank you very much, Amanda. And thank you for joining the webinar also from myself. So let's get started and see a little bit very quickly the agenda about what we are going to be talking about today. First of all, I'll make a very quick introduction about Iconix. Then, since our focus today is going to be about the news on Hyperhistorian, I'll give you first a little overview about it, just for those of you that are not extremely familiar with the module. Then we are going to dive directly into what the new features are, the data exporter, the Hyperhistorian AssetWorks support, and a little bit about introducing the expression editor within Hyperhistorian. At the end, my colleague Jan will give us a demo with all the features that we just talked about during the slides. Now, without further ado, let me show you, let me talk a little bit about Iconix. Iconix is a multinational company, has been founded in 1986, and is based in Foxborough, Massachusetts in the US. We are actually present in more than 100 countries with a wide range of partners that go up to more than 400. As of today, since the beginning of the company, we have more than 375,000 installations worldwide. Iconix is a long-time Microsoft partner, and we started as a gold partner, and recently we also achieved the level of co-selling partner. Recently also, there's a big news in Iconix that we became a part of the Mitsubishi Electric factory automation group. So we are really getting bigger and bigger in order to support you as best as we can. The Iconix technology can be found in many different industries, many different markets. We go from energy, smart buildings, smart cities, manufacturing, power and water utilities, oil and gas, public infrastructure, so a little bit of everything because of the flexibility of our software. Here is basically a little extra markets that we cover. There's also government and military because our product has got several certifications for cyber security as well. There's going to be a webcast that's going to talk about it. And then mining, pharmaceutical, sustainability, and so on. So with a little bit with that, let's start overviewing a little bit Hyperhistorian if you're not familiar with it. What is it? Well, Hyperhistorian, as the word says, is a really powerful historian software that allows you to collect the data from multiple different collection sources. It can be OPC UA, OPC Classic, BACnet, SNMP, web services, and so on, as many as you want. The beauty is that you can also integrate non-structured data through MergeWorks, which is a feature that we're going to be talking about in just a couple of slides. We can have also distributed loggers in order to increase the speed of data logging and also store and manage data within the overall project architecture. At the end, all the archived data can be visualized and analyzed using many different tools, such as internal performer calculations, 3D graphics, reporting, and so on. A little bit on the hyperhistorian architecture. As you can see, there is a centralized system that gets data from many different data sources. We can have data straight back into the hyperhistorian server, or we can also use remote data collectors. And the application server is going to take care about data logging, all the data, about calculating the performance calculations, and also in case this is required, is going to take care about redundancy synchronization. The configuration for this will be done through the workbench. My colleague Jan will show you about this in his demo. And the data can also be exported and used by analytics modules, can be posted to external storage, and so on. And everything can be visible through multiple client technologies, such as desktop, web, tablets, mobile, or even wearable devices. Which are the basic features within Hyperhistorian? Well, the first one is the logger, which is a high performance logger, is absolutely scalable. So you can, in very complex applications, so you can have it scaled to many different servers, and you can have basically scaling up to unlimited number of tags. It's using a 64-bit operating system, can be redundant for mission critical applications, and recently also we have introduced the support for network area storage systems. The data that can we process are any format, from Boolean to string integers, arrays, and so on. You can decide to also store aggregated values such as minimum, maximum, average, and perform calculations as much as you want. Collector is another important part within Hyperhistorian. Is the module that basically takes care about reading all the data that are coming from the outside. The collectors are also backward or forward compatible since version 10.6, so since a few years ago. Data availability is always ensured by the collectors, which can be redundant, and they have a pretty sophisticated system about store and forward data buffers to keep the two servers aligned. We can have different technologies about filtering the data and also aggregating the data. Now, what about you have already historical data in your plant, and of course you don't want to get rid of them, you want to import them inside. We have introduced a new type of collector, which is called MergeWorks. Basically, MergeWorks will allow you to import data from almost any type of source, like TXT files, devices without OPC interface, and other databases, other historian software, other SCADA systems, anything that you might think about. The configuration is done through Workbench, and you can also trigger data so that these merge is going to be done automatically. Inside the Hyperhistorian, there's also an extremely powerful capability, which is called the performance calculations. So instead of just data logging raw values, you can also just data log calculations that are used, for example, to totalize your data or to create some specific KPIs, or just some statistical informations and so on. So instead of filling your storage area with unwanted information, you can just archive whatever you really want to. And these calculations can also be scheduled on different triggers and are accessible as normal standard data tags, so they can be used in our viewers as well. In case the performance calculation really exposes your proprietary algorithms to do some KPI calculations, then you can also create an external custom function, which will be recalled by Hyperhistorian to store the data. But in this way, you will continue to hide your intellectual property so that nobody can really access to whatever you're doing. At the end, the archived data are also available for third parties software, and they can be linked and viewed as with our SQL query engine, which Hyperhistorian is equipped with. And you can do many different things with this, getting information from the historical base. Now, let's see what we have new in 10.6 release and what is really a game-changing technology in today's historian systems. The first one is the most important one, is called the data exporter. What does it do? Well, pretty much is part of the Hyperhistorian process, and is an easier way basically to extract the data and push the data into other sources. And in this case, we are primarily speaking about large data lake systems and, for example, cloud-based SQL databases or other different type of analysis software. The configuration will be found in Workbench, and this is an extension module. So eventually, if you don't need it, then you can decide to disable this data processing and just enable it whenever you want it. Now let's take a little closer look about how the exporter function is structured. We still continue to get the data from many different sources, and through our internal framework, these data are pushed directly to the Iconix client, or they are pushed inside the Hyperhistorian server. Then we have the data exporter, which grabs the data that you selected and pushes them to the cloud. As soon as we have the data inside the cloud, we can have them inside an Azure-based SQL database or Azure Storage or any other type of application which is within a typical data lake structure. And the good part about it is also making this data very easily accessible for other business intelligence tools such as Power BI, machine learning, and more, which can directly subscribe to these data lake connectors. Some general features about the data exporter. First of all, we need to identify a synchronization schedule with global triggering. Synchronization can also be done manual, so we have to understand when do we want to really export this data. Then there is a data set. We will need to create a data set which will be exported into the cloud. And there is the support for different data storages and filters as we have seen before. Now, a good feature also is that the filters can be also aliased, so that you don't need to write them specifically, but you can also use them as much as you want, diverting them to different applications. We need to create our data sets. So we need to tell the exporter which are the data that we really want to export. And of course, most of the time, we don't want to export just raw data, but we want to organize this data in a much simpler way. So the data sets can be organized and very similar to a select operation for databases with a where clause like SQL queries. Columns in the data sets can be defined by users, so we can decide which are the data that we really want to push out to the cloud. one data set can contain values from a single data point, and array values can also be distributed across many different columns, and each row can also contain multiple data points. The same tag can also be mapped to different columns, just in case we want different features about the module itself. Next, then, is storage. Where can we store this data? We can store them into file-based or table-based systems. Data can also be organized based on schedule. So I can have a table, for example, that shows me the data, aggregated data every Monday or every third Saturday of each month, and so on. The connection strings can also be aliased, because depending on which data I'm exporting, I would like to export them in different tables or in different files. And storages that are currently supported are SQL Server, Azure SQL, Data Lake, and we are working on new technologies as well. Let's see very quickly about the data synchronization. So first of all, we gather the historical data, and we organize them eventually in data sets. We have the data set reader. The reader organizes the data, sends the data to the exporter, and then the exporter writes the data set directly into the destination data lake. So it's quite simple and quite straightforward. The task processing here. So basically, when do we want to do this? We can use the typical standard Iconix triggering system, like you would find in ReportWorks and many other modules within the Iconix suite. And also we can decide to recall manually some synchronization tasks. Then once the task is scheduled to execute, it starts, it goes into the processing queue, and then it goes into the writing sequence. This can also be done in parallel, so you can do multiple things on the same time. If something fails, it goes back into the queue for retry, and you can set many different retrial methods. You will find the data exporter within the workbench configuration under the Hyperhistorian part, a dedicated session. My colleague Jan during the demo will show you precisely about this directly. Now, this is all about the data exporter. Let's take a quick look about another new feature in 10.96, which is the integration between Hyperhistorian and AssetWorks. So before, until now, what you have done, you had to configure your historical tags into the Hyperhistorian configurator. And then if you wanted to clone these tags multiple times referred to different assets, you couldn't do it. So you had to do it manually. Now what we have done, we have integrated AssetWorks with Hyperhistorian. So what you can do directly from the asset configuration within the workbench, identify different tags to be also stored by Hyperhistorian. So this way, they both share this configuration database, and you won't need to do this configuration twice into 2 different times. Once you put the application in runtime, they will both access the database and gather the necessary informations. This is a little chart that shows you exactly how this system works. We have the centralized configuration database where we have the configuration data both from for asset and for historian data as well. So the beauty of this is having a one single configuration database. So we won't need to have problems about forgetting one tag configured in AssetWorks that should be also stored within Hyperhistorian. Everything will be done automatically. There is going to be a synchronization mechanism between the two configurations. But also, we are not removing the possibility to configure specific tags within Hyperhistorian itself. The only thing that we need to really care about is that items configured in AssetWorks cannot be modified within the Hyperhistorian configuration. The scope of integration, as I mentioned, is about defining the historian tags. All the other standard Hyperhistorian configurations will still need to be done within Hyperhistorian. So how the archiving is set up, the logging groups, the collector groups, and so on. The last feature before I end up to Jan for the demo today that we have introduced in Hyperhistorian 10.96 is about expressions. So if you wanted to do a little bit of data management before storing a value, before you had to refer and use the calculation tags, even though you didn't really need to. But now, directly when you configure and point a single data point, a single tag, you can also write a little bit, a little expression using our expression editor, so that you can manipulate the data a little bit before. So now what I'm going to do is I'm going to turn it over to my colleague Jan, making him the presenter, and then he'll guide you through the demo for today. And from myself, I wish to thank you for joining this. And Jan, please take over.
Thank you, Roberto. I'd like to continue with presenting some demo features, and I'd like to introduce you first the configuration side and then the results in runtime mode. So as Roberto presented, we have several new features. Now you can see I'm currently in Workbench, which is our central location for all Iconix backend server setups. And here I will introduce you three new features. The main part of the demo will be talking about new Hyperhistorian exporter tool. This exporter tool can be found under historical data section in Hyperhistorian structures. Here, this item is new from version 10.96, and later I will show you how to configure it and what it does. But before we will focus on this data exporter, I'd like to show two other new features, because before we can export some historical data, we need to log them somehow. Till the version 10.96, the only way how to configure historical tags was in Hyperhistorian itself. We were able to create new Hyperhistorian tags in the configuration of Hyperhistorian. But from version 10.96, we have introduced support of Hyperhistorian tag creation under our AssetWorks. AssetWorks became core of most of Iconix projects. It's like a tool for structuring the data, for mapping the data points. And as you can see, in AssetWorks, you can create your hierarchy structure from the top level to the lowest part of the configuration, which is the data point, the asset property. And in the asset property, we were able to define a real-time point and connect it to the historical tag. But from version 10.96, we don't have to only connect the asset property to existing Hyperhistorian tag, but we can even create it. Under source type, at historical data tab, at asset property, you can define, you want to define hyperhistorian tag, or you may want to define calculated tag or condition tags. The settings below looks like standard dialogues as it used to be in older versions and as it is under hyperhistorian settings now. So benefit of this is all the configuration is at the same place, at the same location in AssetWorks. All these tags are normally browsable in the clients as standard assets or historical tags. When we define the historical tag, we may use the feature introduced by Roberto, and it is using of expression engine on the data point input. So till version 1096, only possible input to historical tag, as you can see here, was some OPC tag without expression. But from version 1096, we are able to not only browse for the OPC tag, but also apply some functions. The expression editor is available here. You can use all the set of Iconix expression functions. You can browse for other points and calculate between these points. And the result of this expression is evaluated, and after the evaluation, it is logged. So hyperhistorian gets to its input the evaluated value, and then it logs it to the historical files. So that was short talking about creating historical tags in AssetWorks and introducing expressions in historical tag inputs. And now let's focus on the main topic, hyperhistorian data exporter tool. Till version 1096, Iconix had limited ways how to get the data out of proprietary hyperhistorian files. But from this version, we have this tool, and it's user-friendly. You can define what type of data you want, or how the data you are exporting should look like. You will do that under dataset section. You will define what's the location of exported data. You will do that under storage section, and you will define how often you want to export and what data from datasets you want to export to which location in data storages. I will focus on the datasets because from my point of view, it's very interesting talking. On the datasets, you can choose either exporting raw data at storage data option. So exporter will simply take what hyperhistorian logger logged and will export it to the destination, to the location you define under storages. Or you can use aggregated feature. And that means that the hyperhistorian exporter will not only take the data from the hyperhistorian logger file, but it will even do some post-processing. So while the export, it will apply either aggregations. In this sample, you can see I'm applying average for the data sample. I can define looking aggregation for minimum. I even can use calculation here. So in this example, hyperhistorian logger is logging pressure value in PSI units, and by the calculation, I'm converting the original PSI units to bar units. So the exported value will be enhanced, or the exported samples will be enhanced for this column. And when you define what columns you want to export, when you define which columns you want to enhance, you can or you need to define also the source for the data. You can define either one hyperhistorian tag, or you can define set of hyperhistorian tags, or you can define a complete folder or complete hyperhistorian structure and export all the tags you want. You can also define you can define what type of hyperhistorian tags you want to export. You may say you want to export just raw data, or you want to export just aggregated data, or you want to export just calculated data. That can be done here under variable type filter by writing specific symbol, which is R, C, or A. When you defined data set, so it means what you want to export, you need to define where you want to export it. Under storages, you can select from several storage types. In my case, it's Azure Data Lake. The other options are Apache Kafka, Hadoop, local CSV file, or SQL servers. For connecting to the data lake storage, you need to fill mandatory fields here. All of them are available at the Azure portal. And when you define where you want to export, you need to define how often. You need to define the task. Under the task, you define what's the storage, how often you want to export, how often you want to create new file. So that's the same like in hyperhistorian logger. And you specify what data sets you want to export. So in my case, I'm exporting filling pressure aggregation to data lake storage, and I will do that every 5 minutes. That would be all about the configuration. Let me show you the results, or how it looks like. What's the benefit? First, the expression on hyperhistorian tag input. Please focus on the bottom part to the trendworks. I will browse for my asset property, and here you can see trends. The green bars represents, in my case, it's production of bottles on filling lines, and the blue bars represents 6-packs, so boxes of the bottles. So I have applied the expression saying bottles divided by 6 and rounded to integer means or represents boxes. So this is how the expression on hyperhistorian tag input works. Simply, I have divided input value before it was logged. So the logged data are already divided and represented by blue color here. Now, please focus on the top grid, where you can see how the data looked like when they were exported from the hyperhistorian by our older tools. You were able to get point name, timestamp, status, value. But now, when we have the hyperhistorian exporter, and you are able to enhance the data, or you can apply some post-processing of the data, you are able to, for example, here, take the point name and parse it to meaningful naming. So I took the point name and parse it to the city level, Pilsen, area, which is brewery, filling line, filling pressure is the equipment, is the unit. You can take the description from historical tag. And here is the real logged value, its value in PSI. And I'm calculating on the exporter level aggregates, and I have 30 minutes aggregates for average, for minimum, for maximum. And as the last column here, I have calculated converted value, where I converted PSI pressure to bar pressure. units. And all these data were processed by exporter, because exporter took the raw data and made aggregation, made the enhancing of the columns, and exported it to the destination. Now the proof, the data goes to the Azure. I'm opening Azure portal, where you had to define some resource group. Within you define the data lake storage. And when we expand the data lake storage, we will see under Data Explorer folders I have created by the Hyperhistorian Exporter tool. I've tried to create several folders, but the current data or the data currently running to folder 4. And here is one of the files I created, and the structure of the data located here in Azure in cloud is the same. It has the same columns like you can see in my preview here in HTML5 display running on any gloves from Iconix. Yeah, so we exported the modified data to the Azure, and then it's up to users how the data will be used. And that's all from my side.
Thank you very much for that informative presentation. Let me switch to my screen here and show you my conclusion slides. Okay, and now I'd like to talk to you about the Iconix Worldwide Customer Summit Transform 360. We recently rescheduled this in-person event to May 4th through 7th, 2021 at Foxwoods Resort and Casino in Connecticut. If you already signed up for the event and you'd signed up for the previous dates, we've just moved your registration already to the new dates, so no action needed on your part. If you haven't already signed up, I encourage you to do so. This event is going to be bigger and better in 2021. We have a number of exciting guest speakers lined up, as well as compelling demos to show you. If you register by April 19th, you can do so at iconix.com/transform360. We have a number of promotions that we put up on our social media pages from time to time, including complimentary registration promo codes. So I encourage you to follow us on social so you can see those and sign up. I really hope to see you all there at this live in-person event. I'd also like to share with you a number of on-demand webcast recordings that we have available at iconix.com/webcast. If you've enjoyed today's webcast, you can see the other topics that we have covered this year. And not only do we have these North American webcasts, but we also have a number of international versions as well. And then I'd like to, before I take questions, give you the information for our presenters today. We had Roberto Penso and Jan Rabicha. You can see their emails there. If you do have general questions on the webcast today, you can also email us at webcast@iconix.com. We also have the number here where you can reach us. And then we have some of our solution sales engineers here listed by North America and international, whom you can contact if you have any needs or questions or you'd like a personal demo of some sort. So with that, I'm going to get into questions. Got a lot coming in, so bear with me. Roberto and Jan, the first question that came in is, which data storages Hyperhistorian Exporter support?
Okay, so currently we support Apache Kafka, Data Lake running on Azure, Hadoop. We have also support for local CSV files, and we do support SQL, SQL. It can be Azure SQL or local SQL server.
Okay, thank you. The next question that came in, what license is needed? I believe Hyperhistorian's Standard and Enterprise, not Express.
Yes. When you would install your Genesis suite without Hyperhistorian checked the installation, you will not be able to use the exporter tool. So you need at least the standard version.
Okay, thank you. The next question I can answer. A lot of people are asking about the recording. Yes, this webcast is being recorded, and we will send that to everyone after the webcast. Another question that came in, does Hyperhistorian use a data compression method?
Yeah, I can answer to that. There are pretty much two major compression data criteria. The one is the standard deadband filter, and the other one is a very sophisticated algorithm which is called the swinging door, which basically not only follows a typical deadband compression criteria, but also follows the angle and the increase of your data, so that is able basically to compress more than 70% of your records.
Okay, thank you, Roberto. Another question, can Data Exporter be used for on-premises databases as well? If so, are connections to Oracle databases supported?
I can answer to that if you don't mind. Basically, yes, we do support on-premise databases, but for the moment is only SQL Server. And as far as the cloud goes, then of course any other type of data lake. For the Oracle support, I know that there has been some plans to include this also in upcoming releases.
Okay, thank you. And let me just pull up this next question one moment. All right. Is it automatically available after I upgraded from an older version?
Okay, I can answer it. Basically, Hyperhistorian Exporter tool needs some database background, and older version didn't have it. So what you need to do after the upgrade of your Genesis installation, you go to Project Settings under Workbench and enable the Hyperhistorian Exporter by checking. And then you need to enable this extension under Hyperhistorian settings. So basically what you need to do is only check this, and then you can use it.
Okay, thank you very much. Let me go here. Is Hyperhistorian a separate module? Can I do all you're talking about with the latest version of Genesis 64?
I'll answer this. Hyperhistorian is a completely separate and independent module. It doesn't need any other Iconix software tool, and can also be so integrated with the existing SCADA system or competitor software.
Thank you. All right. I'm going to take a couple more here. A lot of questions on this one. The next one says, looks like you've made some really awesome changes to the Hyperhistorian. One question, when exporting a data set that contains multiple tags to a CSV file, how are the data arranged? Is the data exported in a tabular form, an array? Which one of you wants to take that one?
Yeah, basically the data in the CSV file are divided by delimiter, and they are represented, or every signal is on one row. Basically the structure looks like input for ManageWorks plugin, for example. So it's up to you how you will define the columns, but the structure is defined by the tool, and it's delimited by column or semicolon.
Okay. Next question here. So I'm going to take just a couple more because we have 1 minute here. So I often need to provide several days worth of data for a singular point. Currently, I use Historical Reader and convert that information to an Excel sheet. Is that still the better option, and to use Data Exporter for more regular, larger data sets? Do you want me to reread that one?
No, I can answer to that, and that's exactly one of the purpose of the exporter, is to make this process much easier for you. As we were showing in the demo in the presentation, you can have a single tag also different properties split among different columns, and different rows can also be records for the same tag across a period of time. So that will absolutely improve the method you're doing right now.
Okay, thank you. And I think maybe we sort of answered this one already, but is hyperstoring consuming Genesis 64 tags?
I think I can take that one as well. No, as we said before, Hyperhistorian is completely different, independent module. So it has his own licensing method, which of course is absolutely the same as Genesis 64 in terms of tag ranges, but it consumes his own tags. So you can have, let's say, a Genesis 64 500 tags with an Hyperhistorian 1,500 tags. They are completely, totally independent.
Okay, great. All right, well, I have a ton more questions that I'm going to get to offline because we have passed our 10:45 Eastern Time mark here. Thank you all for taking the time to join us today. We hope you learned a lot about Hyperhistorian. And thank you so much, Roberto and Jan, for presenting for us today. Hope to see you all in the next webcast. Thank you.
Thank you very much.
Thank you.